Hello everyone. In this video, I will be describing a data structures project called as XOR single linked list, which we have created in our second year of engineering. An XOR single linked list is a memory efficient linked list which imitates a doubly linked list. Let us understand what a doubly linked list is. As shown here, a doubly linked list is a linked list in which every node in the list will have pointers to the preceding node and the successor node. By this, we can traverse the list in both the forward direction and the backward direction. However, the disadvantage of a doubly linked list is that we have to maintain memory space for 2 pointers for every node. So what this means is that we are wasting memory for storing the memory addresses of 2 nodes, that is the preceding node and the previous node. Now the XOR single linked list is an attempt to reduce the memory usage for producing a doubly linked list. So what I need to say is that we are going to imitate a doubly linked list with half the memory allocation required for the doubly linked list. The process of achieving an XOR single linked list is as follows. So as said, we have a single linked list. So what this means is that we have only one pointer which points to the address of the next node. So this is a single linked list. However, an XOR single linked list works in a different manner. In an XOR single linked list, every node has a pointer whose value is the XOR of the address of the previous node and the address of the next node. For example, if I name this as A, this as B, this as C, then the pointer value of this node will be the XOR of A and C. So the pointer value is the XOR of the addresses of the nodes A and C. If we consider the terminal nodes, the pointer value would be null followed by XOR followed by the address of the next node, that is B. And if we have this node, then the pointer value would be the previous node's value, that is the address, XORed with null. So in this way, every pointer, every node in the XOR single linked list will have a pointer value, which is the result of the XOR operation of the previous node and the next node. Now, as said before, in a doubly linked list, we can traverse in the forward direction or the backward direction. Now let us understand the process of forward traversal. In forward traversal, we have to move from the node A to the node C. To do so, in the XOR single linked list, we use the following process. We perform the XOR of the preceding node's pointer value, the preceding node's address, and the current pointer's value. For example, if we consider the node B, if we want to go to the node C, what we do is perform the XOR operation of the previous node's value, which is A. So this is the address of the previous node, and the value of the pointer of the current node. That is, in this case, for B, the pointer value is A XOR C, like this. So the parenthesis is important in this case. So when we perform the XOR operation like this, the result of this operation will give us C, which is nothing but the address of the next node. Hence, we have now traversed to the node C from node B. Suppose we are at the node A and we want to go to the node B, hence we perform the XOR of the previous node's address and the current node's pointer value. So in this case, if we want to go from A to B, we have to perform XOR of the previous node's value, which is null, and the current node's pointer value, which is null XOR B. So when we perform this operation, we will get the address of the next node, which is B, and hence we have now moved from A to B. This is the process of forward traversal. Now, let us explore the process of backward traversal. In backward traversal, we have to move from the node C to the node A. To perform this process, we use a similar approach as before. What we do is that we XOR the address of the next node, that is in case of C. So suppose we are at C and we want to move to B. What we do is perform the XOR of the next node's address with the current node's pointer value. So in case of C, what we do is that we perform XOR of null, which is the address of the node following C. So since there is no node, we have null, XOR with the current node's pointer value. So we have B XOR null. When we perform the XOR in this fashion, we get the address of the node B. Hence, we have moved from the node C to the node B. Suppose we are at the node B and we want to go to the node A, we perform the similar process. We take the next node's address, that is C, and then we XOR it with the current node's pointer value. The current node is B, whose pointer value is A XOR C. So what we do is we perform XOR of C and A XOR C, giving us the address of the node A, and hence we have moved from node B to the node A. In this manner, we have covered both forward and backward traversal in a single linked list. Hence, we have reduced the memory usage of a doubly linked list by half. However, the complexity of the insert operations and the delete operations will increase slightly because of the need for using XOR for insertion and deletion. Now, in order to verify whether XOR works like this, we can simply use binary values, such as for this we can use 0, 0, 1, here we can use 0, 1, 0, and here we can use 1, 0, 0. And for null, we can use 0, 0, 0. And in this way, we can confirm whether all these things, that is the addresses and the XOR operations, indeed give us the forward traversal and backward traversal in the correct manner. So in this way, we can verify the working of the XOR single linked list. Now, I will not be describing the process of insert and delete in this video. I will directly go to the program. The program has been run in the online GDP compiler. In the online GDB compiler, we can run various types of languages. For example, I have chosen C. The reason why I chose C for this project was that C has the concept of pointers and structures together with which we can implement any kind of data structure. Also, the execution speed in C is one of the fastest. Hence, we have chosen the C language for our data structure project. In online GDB compiler, we can either upload the file or we can directly paste the code in the editor. Right now, I have placed the code in the editor, and now I will execute it by clicking on the run button. So when I click on run button, it presents me with 4 options. The 4 options are insert, delete, forward traversal, and backward traversal. So before we can perform any operation, we need to check whether pressing 2 for delete causes any deletion or not. So let me click on 2 and check what happens. So it says that the list is empty. So this is as expected because we have not inserted any elements in our list. Now, let us see whether forward or backward traversal works. As you can see, it is saying that it's an empty list and hence it's not showing any kind of elements. Similarly, for backward traversal 2, it should show the same result and it has said that it's an empty list. Now let us explore the XOR single linked list by inserting some elements in the list. So if I click on 1, it says the element and the position at which it is to be inserted. Now, suppose I insert an element 13 at position 2, it says an invalid position because the list is empty. Then what is the purpose of asking the position? The purpose is that if we already have elements in the position 2 and we want to replace it, then we want to insert at that position, then we can use the insert operation. So what I mean to say is that suppose we have these 3 nodes and now I want to insert a new node at the second position. Hence, we will perform the insert operation in such a way that the first node will be linked with the new node and the new node will be connected to the next node of the previous node. Hence, this is similar to the insert operation of the doubly linked list. However, we need to keep in mind the XOR operation which is taking place. Now it is saying that the position is invalid because the list is empty. We don't have any element at position number 2. Now instead, let us put 13 and 1. So before that, let me put 1 for insert. And let me put 13 and 1. That is, in the first position, we will enter the element 13. So it has said that node with data 13 has been inserted at position 1. Let us verify that if we perform forward traversal. As you can see, it is showing 13. And the backward traversal also shows the same result, 13. So now let us insert one more element into the list at position number, say, 2. So I'll put the element as 14 and 2. Now let us perform the forward traversal. As you can see, it is showing 13 and 14. And if you perform backward traversal, it should show 14, 13. Let us check whether that's the result. It is showing 14 and 13. Hence, the forward and backward traversal are working as intended. Let us further explore the XOR single linked list. Now let me put one more element at the third position. Let me put it as 15. 15 and 3. So it is saying that node with data 15 is inserted at position number 3. Let me confirm that by performing the forward traversal. So it's showing that 13, 14, 15 as expected. Now I want to insert 16 at this position. Let us say I want to insert 16 at position number 2. Hence, the result will be that the list will be 13, 16, 14, 15. Let us verify if this is the process. Now, I will put 16 and 2. So it's saying that notebook data 16 is inserted at position number 2. Now let us verify the result by performing forward traversal. As you can see, 13, 16, 14, 15 is the result, which is as intended. This is exactly similar to the doubly linked list, in which we can insert an element at any position in the list. Now, let us perform the delete operation to check whether the delete operation also works or not. So for this, let us put option number 2. It asks me the position at which the element is to be deleted. Suppose I want to remove the newly created node 16. So for that, let me put the position number 2. So it says that the deleted element is 16. Now let me perform the forward traversal. It is showing 13, 14, 15 because the element number in the element 16 has been removed from the linked list. Let us delete the element at the third position, which is 15, and verify what happens. So let me click on 2 for delete, and let me put the position as 3. It has said that deleted element is 15. Instead of forward traversal, now simply let me do backward traversal. As you can see, it is showing 14, 13. Hence, we have performed both kinds of traversals, that is forward traversal and backward traversal. We have performed the insert operation, and we have also performed the delete operation, which are normally available in the doubly linked list. But this type of implementation only requires half the memory space required for a doubly linked list. Hence, this is much more efficient compared to a doubly linked list. Now, to simply exit from this program, I will click on any other number, and we have exited the program. Hence, this is our project of XOR single linked list, which is an imitation of the doubly linked list with half the memory space. Thank you.